Welcome to Learning Module 4. In this first section of 4a, we're going to talk about business process management. And I love this quote by Dr. William Deming. If you can't describe what you're doing as a process, then you don't know what you're doing. And he didn't mean that to be negative or snarky. He just was making the point that if you can't see the pieces of what you're doing, and lay it out and understand really the groups of activities and how they tie together, then you probably don't know really what you're doing. So let's take a look at process. Okay, in this first section, we want to be able to understand what business process is and why processes are so important to firms, to their success, and possibly to their failure if they're not good at processes. We want to look at process maps for a business process and how maps are used to understand and diagnose what's going on inside a process. We sometimes ask about the importance of having a process orientation to our work. Why are we so concerned with these processes? Well, they're how we work at the task level to build value. So when we link together a series of activities to accomplish whatever business goal it might be, it could be paying our suppliers, could be getting paid, could be selling activities, it could be manufacturing items. It can really be any aspect of the business where we link activities together, which is pretty much what we do all day long everywhere in business. So inefficient or ineffective processes will result in poor performance, and if it's bad enough, business failure. A hallmark of great organizations is great processes. So excellence in processes will improve competitiveness and improve business performance. And the inverse is true also, that if we're not very good at our processes, then we're going to have a lot of different results every day. And every time we do things, we'll have different outcomes. And we'll have a hard time improving because we don't have a stable base where we do know what we're doing. So business process, let's define it. A set of logically related tasks or activities performed to achieve a defined business outcome. So let's do A, and then B, and then C, and then D, so that we accomplish whatever this desired and defined outcome is. A primary process is a process that addresses the main value-added activities of an organization. Okay, and it could be manufacturing something, it could be engineering products, launching products. They're the main core activities that allow the business to exist. A supporting process is a process that performs necessary but not necessarily value-added activities. So the value-added concept, if you remember, is most often defined as things that the customer is concerned about and will pay for. So engineering a great product is something that drives value for the customer, and they're usually willing to pay for those things. They're often willing to pay for it, especially if it's a custom product. On the other hand, setting up HR systems and so that we can hire well, and IT information systems so that we can run our business and manage our transactions. The customer is less concerned with how we do that, and it's more of a supporting process. Development processes are processes that seek to improve the performance of both the primary and the support processes. So those are continuous improvement activities. They could be things like Six Sigma projects or various ways that the business engages and said, let's fix something. That's a development process. Okay, so here's a chart that I like because it gives us a chance to mention how important it is that businesses that cut across different functions, and especially that cut outside of our organization to our trading partners, can be very powerful. Competitively, they can add value to our company. Why is that? It's because they're hard to do. It's hard to integrate process outside of your department. It gets a little harder. Inside your group and your function, you have authority. You can meet as a team and say, look, we do A, B, C, and if we just pay more attention to B in that process, we'll have better quality. Let's focus on that, team. When we say we're going to do A, B, C, D, E tasks, and D and E are controlled in another group, we have to go and communicate and organize and convince those people it's important. And we have more political power and persuasive powers that we rely on necessarily more than our actual organizational power, right? So it's harder when we integrate across functions, but it's much more powerful. And again, it's the hallmark of great organizations when their processes are not just contained inside a function and falling apart when they leave that function. You'll see it when you do internships, or if you're full-time employed right now. I'm sure you can think of examples and say, yeah, it is a lot easier when it's inside our group. And it does become more difficult and problematic when we have to work with the other teams. That becomes exponentially magnified in both the difficulty and in the value proposition when we talk about integrating with customers and integrating with suppliers and other trading partners and stakeholders. So that is a key point to remember about processes. It's easier when we stay local and small, but less powerful. And inversely, go all the way to integrating with the whole supply chain. It's very difficult, but it's very powerful. All right, so moving on. There's a concept called mapping of processes, and every project manager is a great process mapping person. But people who focus on process are like manufacturing engineers, lean experts and consultants, people that just work on a line that are trained to think in a process orientation. So when we do that, we map the processes out. And mapping is an important part of this learning module, because if you can't map your process out, you've missed really the whole point of process management. It's 101 in process management. So the point is to develop a graphical representation of the organizational relationships and or activities that make up this business process. Okay, we'll look at some examples. So the purpose of mapping is it creates a common understanding. We can look at it. We can show it to other people involved in the process. We can show it to a process consultant. We can show it to our neighbors in the next function and say, hey, would you consider working on this with us, because we think you're actually involved in a way we haven't discussed before. And it also creates some boundaries and says, what do we mean when we talk about the accounts payable process or the process of developing a product for Whirlpool or a customer and so forth? It sets some boundaries around it. So when we talk about that process, everybody can say, oh yeah, it's part of that process. That's the third step in that process, isn't it? It gives us a way to make sense of the situation and not be loose in our discussions, tighten it up. And it also provides a baseline which to measure the impact of improvement efforts. So we can take a process and we can put times down, and we can measure quality of the process, we can measure cost of a process, and then we have a baseline. And we say, let's improve the time of this process. It currently takes 45 seconds or 45 minutes or 45 days. Let's do it better. How should we go about it? It gives a way to manage that as we do our improvement. We have a baseline to work from. So a process map is a detailed map. Identifies those specific activities. It also looks at information, physical flows, and monetary flows of a process. And you'll hear me mention that later, because that's a hallmark of what we call value stream mapping, which is a part of Lean. We're going to talk about it in another module in more detail when we talk about Lean. But process mapping rules are basically identify the entity that will serve as the focal point of that process, identify clear boundaries, starting and ending points, and keep it as simple as we can. The old Einstein adage of make things as simple as possible, but not simpler. Right? So when we simplify, we have to know where to stop. Don't become so simple that it doesn't matter or it gets stupid, but keep things as simple as we can. Here are some typical shapes and symbols that we use for process mapping, and you will need to know these for an exam, so make sure you look them over carefully. But you can see a square with rounded edges is a start or finish point in the process. A step or activity is this rectangle. A decision point, which usually means a yes or a no, sometimes pass or fail, but a discrete type of decision, on, off, yes, no, pass, fail type situation, is a decision point with a triangle, and or a diamond rather, and input or output. So data, data coming and going out of this. Some production or consumption of data can be designated with that. Document created, so that's the universal symbol for document. This, you can remember, this kind of looks like a D, right? So that's a delay. And we look for delays when we're doing process improvements. We say, wait, why do we have this delay? Is it necessary? How long is the delay? If the delay is 5 days, could it be 2 days? Can we get rid of the delay completely? Inspection. And inspection is another thing that we look at when we think about improvement. Why do we have this inspection? Have we root caused why it's occurring? Why are we suspect of a problem there? Can we work somewhere else and not be so suspect that we need this inspection activity? Because inspection is not value added. It's because of another problem. And move or activity. So linking the process from step to step is one thing with arrows, but also are we moving things and taking an action designated with this large arrow. So tasks in a process, they can be parallel or they can be sequenced. The simple point of this slide, So when you look at a process map and you see the arrows going, process flowing in a direction, just remember we can run in parallel, which we're doing here also, right? Task 2 and 3 are run in parallel to task 1. And up here, task 1 and 2 are run in parallel before finished goods inspection, I guess this is FGI. All right, so remember the concepts of parallel and sequence. Here is an example of a process map for the Bluebird Cafe. It's in your textbook. You can look at it any time in there as well. And you'll just see the flow here from when a customer enters the restaurant until the customer leaves the restaurant, right? The beginning and the end of the process. Again, donated with the rounded off corner box. And then all of these activities are, they're rectangular. They look like a square, but they're rectangles. And we see that some things are happening in parallel. So the waitress takes a drink and a food order, after the customer gets seated. Then the waitress goes, prepares the drinks and so forth, and does these activities while the kitchen prepares the food. So the drinks and the food are prepared in parallel. Waitress picks up and delivers the food. She'd already delivered the drinks, delivers the food, prepares the check, delivered the check, processed the check, customer leaves, right? So you can get the concept there that there's activities. Some of them happen sequentially, some of them in parallel. So here's an example of a process with a number of issues in it and problems. And in fact, I'm going to move past this slide and go into the actual map for a moment, because I think these slides actually slow us down a little bit. But if you look here, you'll see, here's the beginning of our process. It's for a distribution center. We've got a document created, but 4% of orders are lost. So somebody's done some analysis here, right? And over time, in a longitudinal sense, they've collected data, and this is what they found. 4% of orders are lost in this paper creation. That's a problem, right? Order sits in the fax. Remember the D? Order delay. This is a delay in the process. Order sits in the fax inbox. 0 to 4 hours, 2 hours on average. Something that if it's important, I'm sure the firm can work on. Here is a movement. So internal mail delivers the fax. Remember the movement or action, activity. And in that sense, we've got 0 to 1.5 hours it takes to do that. 1 hour on average, but 1% of orders are lost. So we've got another quality issue. We have 2 quality issues so far. 1 delay. Here's another delay. Order sits in the clerk's inbox. So 0 to 2 hours it sits, so it might be processed immediately. It might be up to 2 hours, 1 hour on average. So again, if we're worried about time of this process, which we may or may not be, we're starting to see additional opportunities that we could focus on and see what's possible. So here we have an activity. Clerk processing the order takes 5 minutes. A decision. Is the item in stock? Yes or no? Again, a discrete decision. The clerk can notify the dealer, pass it on to plant if it's not in stock. And if it is in stock, the worker can pick the order, 10 to 45 minutes, and 20 minutes on average. We can decide if we're happy and satisfied with that. It wasn't called a delay, so maybe that's a reasonable time. And here's the inspector. Okay, so we've got to check. Remember, inspection. And we can always say, why is it necessary to inspect? Sometimes it is necessary and we need to do it, but is it necessary? 2 minutes to inspect, and 0.5% of orders are incorrect. So it is necessary to inspect, because that's a pretty big failure rate. That's 1 in 40, right? That's way too many to just ship. The transport firm delivers the order, so 1 to 3 hours, 2 hours on average. No history of lost, damage, or incorrect deliveries, so we're pretty happy with this. And the dealer receives the order. So you can see when this gets broken down how the map becomes something we can now work with. And we can dive deeper and peel the onion open, as we say, and go deeper inside these issues and say what's going on with these delays and what's going on with these quality issues. If we were successful and focused on this, over a period of time, and step by step as a team solved these issues, we would have a faster process. We'd have a lot less waste in the process. We'd fill orders faster for our customers. We could eliminate this inspection, and those are all good and valuable things. And I would even take the position, if this is a distribution center and they have all these problems, they may be on their way to going out of business. As we said earlier in this discussion, why are processes important? They can make or break us. If we're no good at what we do, eventually we'll either have costs that drive us out of business, or we'll have dissatisfied customers that drive us out of business. But poor process is not compatible with success. So we looked at some of these. Here's a little summary of the findings. So average time of 6.4 hours, 387 minutes, can be as long as 11 hours for the total time. If an item is not in stock, it would take even longer. So is that important to our business? Does it matter to our customers? Do our customers care? Is this a point of value? And if it is, we better get after it. And of the 6.4 hours an order spends on average in the process, a full 3 hours is just waiting, just sitting in the queue and waiting. So we can definitely look at that. It's just waiting to be processed, right? And that's usually easily harvested if we focus on it. 5% of the orders are lost before they get to the picking area. Unbelievable. So we can clearly focus on that. For the orders that do survive to that point, 1 out of 200 will be shipped with the incorrect item or quantities. So we've got a lot of opportunities here. Here is a type of process map that you need to know about and you need to remember. It's called a swim lane process map. It's a process map that graphically arranges the steps so the user can see who is responsible for each step. So if you look closely at this, you'll see it's a fast food restaurant, and you see the customer coming in and ordering food, and then the order, it doesn't have the rounded edges, so oops, whoever created this document, we could round those edges and be consistent. But anyway, the process starts, and we see then the counter employee across that dotted line, that swim lane, right here. We see it pass over a swim lane to the counter employee. Takes the order, transmits the order, asks for payment, the customer pays. Again, we go back and across the swim lane, make change, retrieve the drink while they're waiting, and then some other things are going on in parallel of that. The grill employee has received the order, retrieved the food, grilled the food, build the sandwich, deliver the sandwich. The fry employee, also working in parallel across this swim lane line, receives the order, retrieves the raw food, fries the food, wraps the food. Both get passed across the lanes back to the counter employee, does the packing, and gives the food to the customer. So you can see how swim lanes can be helpful in process analysis. We can say, where is this being done? Instead of having just a bunch of process, imagine without the swim lanes and without all the employees, what this graph would look like, this diagram would look like, this map, you'd have to constantly state that. Well, the grill employee does that. And, oh, the counter employee is responsible for that. Oh, really? Oh, they wrap the food? The grill employee doesn't wrap the food? No, the grill employee doesn't wrap the food. Okay, I'm glad you told me, right? So we don't have to ask all those questions when we have a nice swim lane. Very useful. Here's a guideline you should be familiar with, and think now about some of the discussions we had, and whether it's the grill with the swim lane or that distribution business that looks like it's going out of business. These are some of the symbols then to tie it back together to what a consultant or a Six Sigma expert or a process expert might do if they went and were looking into a company's processes. They look for the delay symbols, and I mentioned that earlier. Look for that D, that big capital D, right? What causes the delay? How long is it? How can we reduce the delay or its impact? Look at each activity symbol. Is it necessary or redundant? What's the value added? Is the customer paying us to do this? Is it important? Can we prevent errors in that activity? Is it a quality activity that gives a reliable output? Look at the decision symbols, those diamonds. Does this step require an actual decision? Do we need a decision there? Do we want to accept the customer order, or is it simply a checking activity? Is something in stock? If it's checking, can it be automated? Is it also redundant? So look at those decisions and see, are they real decisions? If they are, that's fine. Look for any loops or arrows that show that we've got a rework loop built right into our process, because that denotes, flashing red light, quality problems. So when you see a rework loop as a consultant, you always say, what's going on here? And somebody will say, oh, yeah, we, for some reason, we had to start doing that, right? And if we need a rework loop, we keep the rework loop until we solve the problem. Right? Never be a hero in the process and change it because you think it looks better on paper. We know that processes are as they are for a reason, and we have to be careful when we change them and respectful that every step of the process exists for some reason. And it'd be very arrogant to look at a process and say, well, I've looked this over and I don't understand why we're doing this, so get rid of that, and that. No, you got to dig a lot deeper than that, or you're not going to be a consultant for very long. The last thing on this sheet is, what are the costs associated with this loop or with any step in the process? Okay, so value stream mapping, this slide, is one before that. So measuring and improving business processes. The measures of process performance align really. It's easy in your mind to calibrate back to the things, the dimensions we talked about, competing and strategic dimensions of operations and strategic management. So we've got the quality, the cost, the time, and the flexibility dimensions, and processes can be measured along those same dimensions. So with quality, what's the quality of the performance of the process, the conformance quality of the process, the reliability. We've got labor, material, and quality-related costs in a process. We've got time, the speed and delivery reliability, the mix flexibility, changeover, etc. So we can apply those to process and see what the impact is on those dimensions of the process. Value stream mapping. So value stream mapping is process mapping, but it is a very structured and mature methodology that consultants and lean experts use when they're looking at process. So I would encourage any of you to explore value stream mapping. I do plan to post some materials when we get into the lean module on value stream mapping, and I think it is amazing how important it can be to your ability to provide value to the company when you are process oriented and acknowledging and cognizant of how important and critical processes are, but also when you've started to build some tools so that, when you go into a meeting and say, let's do a value stream map, some people are going to say, oh my goodness, you know how to do that? And hopefully you'll say, well, yeah, kind of, I think so. Let's put this on the wall and see what we've got here. So we'll spend some more time on value stream mapping later in the course, But for now, let's just say it's very closely associated to this discussion on process management. In summary, business processes are important, very important, as they can drive the success or the failure of the business. They integrate across the business and supply chain partners, and they are very powerful. So remember, when we keep them local and tight, where it's easy to control, well, we're being chicken, right? We need to reach out and integrate with other departments and people and functions in the company, and we need to reach out and integrate with customers, suppliers, service providers, because those corporations, those businesses, those firms are doing amazing things and pushing the boundaries on what is possible from a integrated process perspective. We can map processes to see and manage them much better, and we can judge our processes and measure their performance along the lines of the cost, quality, time, and flexibility consistent with OSCM strategic modes. So how does this process contribute to our strategy? Maybe is an easy way to put that. I hope you enjoyed this section, the first section on processes, business processes, and that's it for today.